Carcass and eating quality traits are important for most production systems, as more profit can be made from higher yielding and higher quality carcasses. Currently, there are 7 estimated breeding values available to improve carcass quality and yield. Carcass weight provides an estimate of the genetic merit in weight at slaughter at 650 days of age. Higher or more positive carcass weight EBVs are favourable, as a bull with a more positive carcass weight will produce progeny that have heavier carcasses at slaughter. Let's look at the impact of using a plus 50 carcass weight bull versus a plus 75 bull over the same mob of cows. Since only half the bull's genetics will be passed on to the progeny, it's estimated that the progeny produced by bull B will have carcasses that are on average 12.5 kilograms heavier compared to progeny produced by bull A. Eye muscle area estimated breeding value describe the amount of muscle at the 12th and 13th rib or loin area of a carcass. This trait is measured in square centimeters. Higher or more positive EBVs for the eye muscle area are favorable, as a bull with a more positive EMA will produce progeny that on average have a larger eye muscle. Let's look at a plus 3 EMA bull versus a plus 5 bull over the same mob of cows. Since only half the bull's genetics will be passed on to the progeny, it's estimated that the progeny produced by bull B will have on average an eye muscle area that is 1 centimetre squared larger compared to progeny produced by bull A. Rib fat estimated breeding values describe the amount of fat at the 12th and 13th rib, or simply the amount of fat around the eye muscle. The rump fat EBV describes the amount of fat at the P8 site over the rump. These traits can be selected to be more negative when the production system requires leaner animals, or more positive when the production system is too lean and requires more fat. The direction these traits are selected for and how extreme this direction should be varies with different production systems and may change over time. Let's look at a plus 0.2 rump fat bull versus a plus 2.2 bull over the same mob of cows. Since only half the bull's genetics will be passed on to the progeny, it's estimated that the progeny produced by bull B will have on average 1 millimetre extra fat over the rump compared to progeny produced by bull A. The retail beef yield estimated breeding value describes the amount of saleable beef in a carcass. Larger or more positive retail beef yield EBVs are favourable, as a bull with a more positive EBV will produce progeny that yield a higher percentage of saleable beef cuts. Let's look at a plus 0.6 retail beef yield bull versus a plus 2.6 bull over the same mob of cows. Since only half the bull's genetics will be passed on to the progeny, it's estimated that the progeny produced by bull B will have on average carcasses that yield 1% more saleable beef compared to progeny produced by bull A. Intramuscular fat estimated breeding values, more commonly known as marbling, describes the amount of fat distributed inside the ribeye muscle at the 12th and 13th rib. A larger, more positive IMF EBV is generally more favourable for breeding progeny with a higher percentage of marbling. For IMF, let's compare a plus 1 IMF bull versus a plus 3 bull over the same mob of cows. Since only half the bull's genetics will be passed on to the progeny, it's estimated that the progeny produced by bull B will have on average carcasses with 1% more marbling compared to progeny produced by bull A. For markets where marbling is important, such as MSA or Japanese markets, higher IMF can contribute significantly to carcass value. The final carcass trait is shear force. This estimated breeding value is commonly used in tropical breeds like Brahman. Shear force is a measure of force required to pull a mechanical blade through a piece of cooked meat. This gives an indication of how tough the meat will be. A lower, more negative shear force EBV is favourable, as this indicates a bull's progeny will have more tender meat. Let's compare a +1 shear force bull versus a +3 bull over the same mob of cows. Since only half the bull's genetics will be passed on to the progeny, it's estimated that the progeny produced by bull B will have carcasses that on average require 1 kilogram less force to shear through the meat compared to progeny produced by bull A. By using EBV carcass traits in your bull selection decisions, you can significantly improve the carcass quality and quantity of your herds for many generations to come.